Hello, everyone, and welcome back to Learning with Jelly. So, today we are going to do a crash course of the SAS data step. Now, SAS is made up of two main steps: the data step, which helps you create data sets, it helps you read in data, it helps you create variables, it helps you modify and transform data, and the proc step, which is going to perform some of your models. It is going to help you do statistical functions such as look at correlations, run t-tests, etc. So before we can run any procedures, we need some data. So we are going to focus on the fundamentals of the data step. Now, link in the description below is going to be my most popular video, which was Learn the Basics of SAS in Under 2 Hours. And that video covers both the data and the proc step. However, this video is going to have a deeper dive into the data step, especially for those who are new to SAS or need a good review. So let's go ahead and get started. So the agenda for today looks pretty overwhelming, but I promise you that it will not be. We are going to cover a lot of topics, and I'm going to have this deck linked in the description below so you are able to look at it. I'm also going to share code as well. So we're going to talk about how to get data inside of SAS by discussing libraries and different ways that we can read in data. We are going to talk about those two main variable types, which is character and numeric data, as well as some important statements that is going to be in relation to the variables we create. We're going to talk about how to format what we consider unstructured data. So if you have variables that have commas in it, hyphens, dollar signs, dates, we are going to talk about how to properly format those. We are going to look at some functions such as statistical functions such as summing, averages, rounding, as well as concatenation functions. And that means just joining two variables together. We are going to look at how we can change variable formats using the input functions. So if you're given a character variable, how can you change it to numeric and vice versa? How we can actually drop out data we do not need. Great conditional statements, so very popular in Excel as well as Python. We're going to talk about if, then, else statements. And then finally, when you want to perform more than one action on a variable, we can use a nice little do statement. So let's go ahead and get started by talking about exactly what is this data step. So a data step is going to start with that keyword data, and it's going to be a list of SAS statements. So as I've mentioned, this data step is going to help you read in data, create your own SAS data sets. You're going to be able to do data transformation and a whole lot more. So what is that basic syntax? So each statement is going to end with a semicolon. So no matter what you do in SAS, you need to end every statement with a semicolon. And in order for SAS to recognize that you're creating a data step, you're going to use the data keyword. And most data steps are going to end with that run statement. So notice here, I have the data keyword with a semicolon. Anything else that I add in between needs to end with a semicolon. And finally, the run statement will end with a semicolon. So before we go into actually creating these data steps, first we need some data, right? So let's talk about how we can get data into SAS and how you can read in already existing data sets on your computer directly into SAS. So in order to access data on your computer, you need to create what we call a library. And a library in SAS is just a collection of data steps. And they are going to be created by using what we call a lib name statement. So lib name statements create libraries, and that library is going to point to a file path, either on your computer or within SAS OnDemand for Academics online. If your data is not in a SAS data set, you can read it using Infile statements. And we are going to see this in the next section. So for simplicity purposes, let's say that you already have a data set saved on your computer that is in .sas7b.dat format. So that is going to be the extension for a SAS data set. And we want to bring that data into SAS. So the first thing that you'll want to do is create a folder either within your documents on your computer that has all of your SAS data sets. And then you can create your library. So creating a library using this lib name statement. So there's this term called libref. And a libref is just the name of your library. And the name of your library has to be 8 characters or less. It can't contain any special characters except for underscores. Your libref must start with a letter or underscore, and it can't have any blanks. So the libref is going to be the name of your library, and you create libraries using the libname statement. So let's see an example of this. So if you have SAS downloaded on your computer, you're using the software, the libname statement is here. It starts with the keyword libname, ends with a semicolon. The name of the libref is test. Notice that it's no longer than 8 characters, and it starts with a letter or underscore. And say, for instance, this was the file path of where your SAS datasets were stored on your computer. So my SAS datasets was stored in my documents folder inside of another folder called SAS datasets. What we are going to be using for these tutorials is the free SAS OnDemand for academics. And if you do not have access to this, I'm going to put a link in the description below, but it's free. You can go to sas.com and sign up for it. And in this case, my library I'm calling is course. That is the name. And it's pointing to my specific user ID online, as well as the folder that I created for it. Okay, so let's actually hop into SAS Studio real quick and look at this. And so this is exactly how it's going to look. So in this case, over on the left-hand side where I have several files and folders, I uploaded something. Okay, so I clicked on Files Home and I clicked on Upload, and I chose the folder straight from my documents. Now, when I did that, the folder was course data, as you see here that I have highlighted in gray. If I right click on this, I now can get the properties, and it tells me the location of this. Now, that is the URL or the file path, that I put right in this single parenthesis. So this will be different for you. Maybe yours will be U5578, whatever it is just the properties of the folder that you directly uploaded from your computer. So now when I run this, and I'm going to get like a nice little run. If I expand libraries on the left-hand screen, I now see that I have this new library called course, and I can write new SAS data sets to this library and things of that nature. Okay. So that's exactly how we would bring in existing SAS data sets. All right. So let's continue. And let's talk about the library naming convention. So how do we actually access data sets that were stored in, let's say, the course folder? So you can refer to data sets in SAS by a 2-level or 1-level name. 2-level names would be something like the name of the library. My name of my library was just course, dot whatever the data set was. So say, for instance, I had a financial data set. It will be course.financials or course.test or course.jelly, right? So you can refer to data sets based off of its library and then the name of the data set itself. In this example, you're going to see me use a lot of built-in data sets in the SAS help library. So I'm going to refer to things sashelp.cars, sashelp.class, and so forth. And then there's 1-level names where you can refer to the data set based off of just the name of the data set. However, if you use 1-level names, it is only going to look for that data set inside of your work library. So if you don't give it a library, it assumes work is the library. Okay. And work is a temporary library that once you end the SAS session, everything is deleted out of that work library. So where can we actually find this? If you hop into SAS OnDemand, work library is down here. Okay. So in this case, anything that you do in a SAS session, if you do not have the library in front of it, it assumes that it will save it to your work. And work is temporary. It will be erased. So if you want to have permanent data sets, you need to save it to your course library, for instance, or another permanent library. Okay. All right, so now we talked about how to get already existing SAS data sets into SAS and what libraries are. But what if you don't have SAS data? What if you have CSV files? What if you have Excel files? What if you have text files? All of those great files. How can you get those into SAS? Well, one way that you can do it is with the proc import procedure. And this is going to be one of the only procedures that we talk about in this lesson. But if you have these .csv files, text files, it needs to be specially imported in SAS. And one of two ways. You can either use proc import or you can use the infile/input statements. And we're going to talk about that in the next section or two. So in this case, I am showing you where I'm calling proc import, and the data file is equal to the file path of the CSV file that I want to import. It's not a SAS data set. I want to import a CSV file. I want to save it as Titanic, and it's going to go into my work library. And this database management system tells it that it's CSV. If it was Excel, it'll be Excel here, etc. And that's going to read it straight into my work library. Now, say for instance, I didn't want to do proc import. I could use the infile and input combination. And infile statements are used to read in raw data files, and they always need to be coupled with input statements because input statements are going to list the variables that you want to bring in from that file. So say, for instance, your CSV file has 50 variables and you only want to read in 5, that input statement is going to list those 5 variables that you want to read in. The infile statement is never seen with a set statement, and I'm going to highlight this in a couple of slides, but it helps us actually read in that file. So let's look at this example here and notice how it differs from the previous slide. So previously we did proc import, a procedure. Here is the file path to our CSV file. We want to store it in our work library, and we want SAS to know that it's a CSV file. Here, I'm using the data step where I now want to save this as Titanic 2. It has no library in front of it, so it's automatically going to go to my work library. This is the file path of where it's at. I say that the delimiter is a comma because this is a comma separated file. The first observation starts at 2 because 1 is the header, so I want it to recognize that my first observation starts at 2. And then I'm doing a nice little link statement so it doesn't cut off the characters in my name because I have some people in my data with some long names. So I'm saying, hey, set name to 50 and it's a character. The $ means that it's a character. I'm going to only read in a few columns. Input passenger ID as a character, survived as a number, P class as a number, and name as a character. And this DSD just tells it that in the name variable, there's some commas. So don't separate the name across multiple columns. Keep the name inside of one column. And you're going to be able to see what I'm talking about. So let's hop over into SAS Studio. And this was one way. So we talked about our proc import. We have the data file. I got this file path just by going on the left-hand side and then finding my Titanic and then right-clicking it and finding the properties. This is where I saved it out as. So when I run proc import, I hit my libraries on the left-hand side. I should see Titanic in my work library. And I do, down here at the bottom. Now, using the infile input statement, this is the infile statement, which is going to have where the file is located. It has options. This is the delimiter. The first observation, start at the second row. And within the name variable, there are going to be some commas, so don't split those up. Okay. This is the length statement so that I don't chop off long names. And this is the input statement. So I'm going to read in passenger ID, which is one variable, and it's a character. Survived, which is one variable. P class, which is one variable. Name, which is one variable. And it should be saved to Titanic 2. So when I run this is what I get. I get the name, the passenger ID, survived, and P class. And see within name had commas in it. So since it was a comma separated value file, that DSD didn't read this as the name stopping at Brond, right? It kept it for me. So now when I go into my libraries, in my work library, I see that now I have Titanic 2 that was saved to my work. So these are how we can actually import non-SAS data sets, okay? So you are going to use a library to import a folder from your computer that has all of your SAS data sets if they have .SAS7 BDAT extensions, or you can use an import statement or an infile and input statement within the data set to read in CSV files, Excel, etc. And that's how we are going to be able to get our data right inside of SAS, no matter what we are working with. Okay, so let's continue. All right, so we have our data. Okay, so we know what libraries are. Libraries is a collection of data sets. You can create your own library using the lib name statement. You can read in raw data files using proc import or the infile input statement combination. But what are these variable types? And I've already kind of alluded to it when we looked at the input statement. But SAS has two main variable types, okay? Character and numeric. Variable names, if you are naming a variable, can be mixed cased, but it must start with a letter or number and have no blanks. Character variables can contain numbers, letters, or special characters. They have a max and they are left aligned. So if we're looking at this example below of a data set, we see that team is a character variable, and I know that it is because it is left aligned. Numeric variables contains numbers and can also contain decimals, and they would be right aligned, as we see in our example here, which is number at bat. Okay. So when you create new variables, you can create character or numeric variables or dates. I personally like to think of dates as a new variable type because we handle them a little bit differently. You can create variables using existing variables that already exist in the data set. You can create new variables using functions, and we're going to talk about functions later. And most of the variables you're going to create is after the set or infile input statements. And I'm going to point that out when we get to examples. When you are creating new variables, and if you're doing this for a data role, a lot of data professionals refer to this as feature engineering. You're creating a new column in the data set or a new feature. Okay. So this is an example that we have here. So this is a data step. Our data statement says I want to create a new data set called baseball underscore country. I'm reading from an existing data set that I already have. So within the SAS help library, I have an existing data set called baseball. And then after the set statement, notice that I'm creating this after the set statement. I'm setting a new variable called country, and I'm setting that equal to USA. And then I'm ending this data step with a run statement. Okay? Because how SAS executes our statements are not always in order. It is always going to read this set statement after the input statement, if I have an input statement. And then from there, it will read other things. And we're going to talk about that very briefly. But I'm creating a new data set called baseball country, reading it from an existing data set, creating a new variable called country that is just set equal to USA. And then I'm going to run that. And that's how exactly I can create my new variable. All right, so now let's look at another example of how we can create new variables from existing variables. So in this case, I'm still creating a new data set. This one is now going to be called baseball underscore salary. I'm reading from that SAS help library, and I'm creating a new variable called salary full that is equal to the existing salary times 1,000. So this is going to multiply that existing column by 1,000. So let's look at how we created these variables right inside SAS Studio. So I'm going to hop over to SAS Studio. We already talked about how we can read in our data. And let's go into actually creating some variables. And I use a different example here, right? With functions. But let's go ahead and try that same variable that I just did. So I'm going to add a nice little step here. A comment in SAS is a backslash asterisk. This is called a multi-line comment. And I'm just going to say creating vars. And I'm going to have an asterisk backslash. So the stars need to hug. The stars are on the inside and the slashes are on the outside. So let's go ahead. So on the left-hand side, I have my libraries expands. I'm going to expand SAS help. And by default, SAS help has a ton of existing SAS data sets that you can play around with. And I think we were looking at that baseball data set. So I can expand baseball and see all of the columns within that data set. If it has 1, 2, 3, that means it's a numeric column. If it has an A, that means it's character. I can double click on it. And here I see all of the information, and I see that we have this salary column, right? And I ended up multiplying this by 1,000. So let's go ahead and do that. So I'm going to do the data step. The data step always starts with the data keyword. I don't want to save this to any permanent library, so I'm just going to call this example. And I want to do the set statement. Now, the set statement is going to be used when you want to read from existing data sets. So if you have an existing data set on your computer that was stored in your course library, it will be course dot whatever that data set was called. In this case, the data set is stored permanently in the SAS help library and it's called baseball. And that's also going to have a semicolon. And now I'm going to say salary full. And I'm going to set that equal to salary times 1,000. It's a statement. It's going to end with that semicolon. And then we have that run with the semicolon. So let's go ahead and actually run this. And I'm going to scroll all the way to the end because that's what it should be. And this is the salary full. So in this case, I have added the right number of zeros behind it. So this person got paid $475,000 for the season, 480,000, and so forth, so forth, so forth. So this is exactly how you can create a variable from an existing variable that already exists in a data set from SAS. So let's hop back over to our nice presentation and let's continue. So I also can create new variables using a function. So in this case, we're creating a temporary data set called error_test. We are reading from an existing data set using the set statement that's stored in our SAS help library called error. And now I'm just extracting the month from my date variable because maybe I want to do month to month analysis. Maybe I want to do what we call a time series forecast by month. So I'm just going to take out the month of the existing column date. And in this case, I'm using the month function. So it should create a nice little feature, a feature that I have engineered called date_month. That's 1, 2, 3, 4, whatever the case may be. All right. So let's go ahead and just briefly look at that. So in this case, I can go ahead and I'm just going to create it underneath our salary. So let's do create a date var. And we're going to look for that SAS data set. So once again, on the left-hand side, I'm going to expand the libraries. I'm going to look at my SAS help library and then the air. And I see with air, I have date. So in this case, I'm going to put data. And I'm going to put air_year. So let's see how we can extract the year. I'm going to read from this existing data set that we're looking at in the SAS help library. And I'm going to set year equal to year of the actual date variable. And then we are going to run this. So it's a temporary data set, so it should be stored in work. And here I get the year pulled out, right, with this new column that I just created. If I wanted to look for that data set, I can expand work and I see that I have air year right there. So that is how we can create variables in SAS. So let's continue. So next we're going to talk about length and retain statements, where If I create a variable and I want it to be a certain length, I can tell SAS what length I want that variable to be. If I only want to retain the order of certain columns, I can tell SAS what order to put the variables in my data set. And this could be very beneficial because I don't want to have variables that are too long, and I'm taking up a lot of computational resources. So people who are like data engineers or they work on the infrastructure, they like to set lengths for their variables. So let's look at this. So the length statement is going to specify the number of bytes of a variable. If your variable is a character, you can use the $sign, then the length to specify that that is now a character variable. It is very important that if you have long variable values, so if you have address information, name information, things of that nature, you put in a length statement so it's not cutting off that information. Just like how we did in the example earlier. So when we did the infile statement to read in a CSV file, and I input the passenger ID, survive, P class, and name, I specified the name to be 50 characters long and as a character variable with a $sign. That way, nobody's name in the data set gets cut off. Now, what does the retain statement does? The retain statement can do many things in SAS, okay? It has many functions. But for this lesson in particular, it's going to be focused on how to reorder variables in the output data set. So in this case, I'm creating a new data set called reorder cars. I'm reading from the existing data set, sashelp.cars, and I want to retain miles per gallon highway, miles per gallon city, and make in the beginning of the data set. This is very beneficial when you don't want to do a whole bunch of scrolling. Say, for instance, your data set is 500 variables and you only really care about 4. Either you can only read in those 4, or while you're doing analysis on that specific 4, you can put them at the top of the data set so you don't have to keep scrolling through, okay? So before, this was the original order of the data set, make, model, and type. And then when I use the retain statement, I see that now I have it in the same order that I specified within that statement. So length statement is going to give us the length of our variables as well as if they're character or numeric. If they're character, $sign. And the retain statement, one function, is going to be able to reorder the variables in our data set. All right, so now let's talk about informats and that raw data. And when we talk about raw data, we mean any data set that is not a SAS data file. So any other file that does not have .sas7bdat. So CSV files, .dat files, text files, all of those is raw data. So informats, what are they? Why are they useful? And this took me a minute to kind of grasp when I was first learning SAS. So it may be something for you to revisit. I also have one other video out on informats that you can also take a look at. But SAS can only read in structured data. So what do we mean by that? It can read in regular numbers and letters. Anytime when you have a variable that is storing special characters, the variable has hyphens in it, such as a date, where you may have 06 hyphen 12 hyphen 88. That is going to need an informat. If you are reading in money, say for instance, you have a variable that has the $sign in it, that is going to need an informat to be used. So when reading in unstructured data, you need these informats. Most unstructured data is going to have some type of symbols in it, hyphens, commas, $signs, decimal points, and dates are a common variable air quote type, because remember, we only have 2 main types. I just like to think of dates as a third type that needs to be read using informats. So let's actually look at an example here. And before we do that, let's look at the main types. So I have a character informat. It's a character informat because it has that $sign. And it's going to just have the $sign and whatever I want the informat to be. So $sign 50, $sign 125. That's going to be the length. I have numeric informats where the D is going to be the decimal point. So I can have weight as 3.2, where it's going to have 3 numbers in front of the decimal point and 2 numbers behind if it has 3.2. And then I have date formats that can read in date. And there's tons of ways you can read in dates. So please look up SAS documentation for that. You have date 9, you have month, day, year, 10, you have month, day, year, 7. There's so many date informats that you can actually read in. So let's look at an example. So I'm creating a data set called MRI in my work library. This is a text file. So I'm using the infile statement with the path to my text file. And since this is uploaded already in SAS OnDemand for academics, I just right click, hit properties to get this. The delimiter here is going to be those nice little tabs or spaces. And the first record is the second one. Patient ID. I'm reading in patient ID as a character, okay, 4. And the MRI date, I am using the month, date, year, 7 dot informat. Now, notice in my example, my MRI date does not look like a date to me. Because one thing about informats is informats will read it in, but it will not translate it to a date until we tell it to. So in this case, I need an informat to read it in, but I also need a format statement so it actually looks that way to my eye. So let's see an example of this. So I've added this format statement here. And notice that I have the same thing. MRI date, month, day, year, 7 with a decimal. Don't forget that decimal. And so now the MRI date that was once just integers that made no sense to me is now in an actual date format that I can understand. December 7th, 1991. September 1st, 1992. August 20th, 1992. So informats only read it in. Format statements make it readable to us. Okay. And that is very important for dates. So let's see how this actually looks within SAS Studio. Okay. So in this case, I'm going to run this step with the format statement comment out. If I just want to do a 1-line comment, I can just do an asterisk, okay? Because it's not a multi-line comment like I see below. So it's going to have an asterisk with a semicolon. Anything that's green in SAS OnDemand for academics is going to be this comment. So I'm creating a temporary set. So where are all temporary sets stored in? My work library. I'm reading in a text file that I have uploaded. So I have server/files. If I find in the MRI.txt, I'm right clicking on it, looking at the properties, and this is the URL that I copied and pasted. It is a text file, so it has a tab delimiter or a space. It has a header, so I'm starting at the second row. I'm only inputting the patient ID. ID should be characters because I'm not doing any math on it. So I want it to be read in as a character. And the MRI date is in math, day, year, 7 format. Okay. So if I double click on this MRI.txt, I can look and I can see the date. I have 1, 2, 3, 4, 5, 6 here. These are the actual dates that are kind of in my file that I have, okay? And the first one is going to be that nice little header row. So let's go ahead and see what it does without our format statement. So I'm going to highlight it and hit run. And I see that it gave me my MRI date. And notice that these are just numbers. So SAS starts at January 1st, 1960 as day 1, and it counts up every day after that, okay? So these are just how many days since that date, okay? But now if I uncomment my nice little format statement and notice that I put it above the infile statement, I see now that my MRI date is actually exactly how the text file looks. So now I have the exact date where this in turn would be November 16th, 1991. So this is informats. Dates need these informats. Please just Google SAS dates informats and you will get tons of different informats that you can use based off of your use case. All right, let's hop back over and let's continue because we're learning a lot. And while I was saying that, I put a side note here that I want you to do some research on about the order of execution for SAS. So SAS is going to execute input statements before set statements, okay? So based off of how SAS executes its statements, which is not always in order that you write them, is going to determine your output. So some statements have to be positioned after other statements and then vice versa. Like an input statement always comes after an infile statement, okay? Things of that nature. So please be mindful of that when we're talking about order of execution, something for you to look up. All right, so let's continue on to common functions. So functions in SAS are going to accept arguments, perform a function, and return some type of value. Most of the functions that you are going to use are going to be within data steps, okay, within a where expression or a where statement and SQL. So when we talk about proc SQL in later lessons, you are going to use some functions. Most of the time, functions are not used in proc steps, except for proc report. There is a whole list of functions that you have available to you that you just have to Google. But as you can see from the screenshot, we have round functions, we have date and time functions, we have sum functions, we have what we call string or character functions where you can extract certain text from a string. You can turn things into uppercase. Of course, we have date functions such as taking out the year, the quarter, looking at the difference in years. There's so many different functions that you can utilize. So we're only going to look at some examples. So in the examples that you see here, there are numeric functions that have statisticals in it, that is statistical in nature, where you can get the sum, the min, the max, the standard deviation. You can round things, you can get the absolute value, you can change things to integers, all that good stuff. So in this example, we have the test underscore fish. It's temporary, stored in our work library. Reading from the existing fish data set, and we're taking a sum of existing columns to get off the total length. We're also creating another data set, or I'm actually overwriting it because I called it the same thing, which I don't really care about this example, so I'm overwriting the data. If you do not want to overwrite your data, make sure you call it two separate things, and I'm just rounding the width, okay? Now, outside of these numeric functions, there are functions for dates, as we've already seen in one of our examples. We can extract the year, the month, the quarter. We can get the difference between years. We can even get what today is. And SAS will perform all of those different date functions. Now, outside of these numerical functions, what might be a little bit more intuitive, we are going to talk about concatenation. So concatenation is a term that you'll see coders, developers, programmers, data professionals use. And most of the time, concatenation just means joining two things together. Okay. So if I have two text variables or two character variables, I can join them together. So we have the cat functions, like meow, the cat. So cat itself is going to concatenate text without removing any space. Cat T, the T stands for trailing, is going to concatenate things and remove any blank spaces. Because why keep the spaces? You're just taking up more space in memory. Cat S is going to concatenate strings and remove both leading and trailing spaces. And Cat X is the most popular one that I use a lot, where I'm going to combine strings, remove the spaces, and specify a custom delimiter to separate them. So in this example here, I have Cat X. I want to combine the make and model, and I want to separate the make and model by a hyphen. So this is very beneficial. And I'm creating a new variable called make underscore model underscore cat X. So in this case, this is the feature that I created that's just cats. And you see how it's just combining two things. It's squishing it all together. Whereas my cat X, I am combining these two things, but now put in a hyphen there, or I can put a space there, whatever I so desire. So this is concatenation, joining two character columns together. So let's look at these functions in SAS Studio. So I'm going to pop over here And here is one of the functions that we talked about. So this is the SAS help.fish. So I'm going to just expand my libraries on the side, go to SAS help. And here I have my nice little fish. I can double click on it to take a quick preview of it. And I see that I have these 3 links, length 1, 2, and 3. And I just want to add those together. So I can do total length is equal to the sum of all of those. And I should be able to get a variable at the end that add all of those values up. Okay. Notice here that I have width, and width have tons of different decimal points. Some rows have 2, some rows have 3, some rows have 4, and I just want to round that. So in this case, I'm going to do width, and I'm going to set that equal to the rounding of that existing variable. So all of this is good when we clean up data, and I see that it rounded to the nearest whole number. Okay, so this is very useful when we want to do data cleaning or we want to create new features. Now, with my concatenation functions, this is the same example that I just showed you, but I'm going to change this to just a space instead of a hyphen. And I'm going to go ahead and run that. So when you're looking at this code, it's always good to kind of play around with it. And in this case, I see now I have the make and the model together that is separated by a space. Okay. So those are some popular functions that you can utilize within the data step. So let's continue back with our presentation. And this may be a good time that if you're learning a lot or if this is a good review, please like, comment, and subscribe. It definitely helps the channel as well as help me create more content for you. So now let's talk about 2 functions, input versus put. And these are functions that I had to look at a lot when I was first learning this. So please, please, please go back and review these. But the put and input functions, all in all, are going to allow you to change the variable type. So you can change a numeric variable to a character variable or a character variable to a numeric variable, okay? So things to keep in mind, and it's explained in this chart here. But the put function always returns a character. Okay. It can only return a character. The input function can return a character or numeric. Okay. The source of the put function can be character or numeric. But the source of the input function has to always be character. So that means the input function can only take in character variables and change them to numeric and or character. The put function can take in either character or numeric, but it will always return you a character. Okay. So that seems a little counterintuitive, but try to remember that. Okay. So let's look at an example. So in this case, I have an ID variable that is numeric. And I want to put the ID as character. And that's sometimes best practice because a patient ID, I wouldn't add 2 to a patient ID. I don't perform any mathematical operations on unique identifiers. So I don't want them to be stored as numbers. I want them to be stored as characters. So in this case, I took the patient ID and it's only 4 values. So I want to change it to a character, which is the $sign. And I always need that decimal point. So this helps me change from numeric to character, just doing the put. And the put will always output a character. Or I could have went around the bush with it. And I could have taken in a numeric, right? Said that I want that numeric variable to be 4 dot. It's still numeric. Then brought in this numeric variable because input can take in a character variable. Okay. And then output it as another character variable and then drop the new ID. Now, this is more of the roundabout way. Don't really recommend this way. But this initial way up here is a good way to look at it. So let's go to SAS Studio. And here I have some data lines. So we didn't talk about data lines in this presentation, but data lines helps you create your own data sets right inside SAS. So it's going to have an input statement with all the variables that you want to create. So I have input and ID. I'm inputting age. And age in this case was a character variable, and I'm putting in salary. So in this case, I have the ID of this patient is 1001. They're 37. This is their salary or employee. And the ID of this employee is 1002. So I'm going to run that, and it's going to be saved as test underscore FX. This is what it gets out. I created a nice little data set. So if I go to work, I should have test underscore FX, which I do. And now I'm going to take the actual ID and change it to character, because here's numeric. So in this case, and I know that it's numeric because it's right aligned. So if I opened up the actual test function in my work ID, my work library, I see that it's right aligned. So it's numeric. So in this case, I'm creating a new column called new underscore ID, which is going to put my ID as a character with 4 values, because I have 1, 2, 3, 4. And then I'm going to drop that ID column because there's no need to keep the original ID in there. So now when I create this, I see that I have a new ID is left aligned. So I know that is a character variable. Okay. All right. So that's exactly how you would go about using things like put and input. Very important when you are reading in data and it needs to just be stored in different ways. Okay, so now let's talk about the drop statement. Drop can be used as a statement or an option. So within the set statement, inside parentheses, I can use the drop or keep options. I know that they are options because they are within the set statement itself. And in this case, it's surrounded by parentheses. So I can decide on what variables I want to keep or what variables I want to drop. So in this case, I wanted to read in the sashelp.class, but I wanted it to be anonymous, so I wanted to drop the name. Okay. Or I can choose to say I want to keep everything but the name, which is age, height, sex, and weight. Which one do you use? It does not matter. Normally, I default to the one that requires less typing. It's easier for me to say drop the name than to keep this and just drop one thing. Okay? But both of them are options and they work the same. Now, we also have drop and keep statements. So it's no parentheses. It actually is a keyword in the beginning of a line. So in this case, once I created that new ID in our previous example, I wanted to drop the original ID. Okay. And it's going to happen after it has created the new ID feature. Notice that I didn't put drop ID at the very, very top. So remember, it matters how SAS executes statements. So just be careful with that. So you can either have drop or keep as an option, or you can have drop or keep as an actual statement. So let's continue. We only have 2 more parts. And let's talk about the important conditional statement. And these are statements that if you have had experience with Excel or Python or pretty much any coding language, you have worked with some type of conditional statements. So conditional statements are normally like this if then else statement, okay? It is used to filter data, it's used to create variables, and it helps reduce code redundancy. Okay? So let's look at the first way, filtering data that I have highlighted in red. So in this case, I only want to create a data set called Asia from my existing data set. Only if the origin is equal to Asia, then output it to this new data set. This then output means output it to what I'm trying to create, which in this case is a data set within my work library called Asia. So this helps me only have a data set that's focused on my analysis if I only wanted to look at Asian cars. Now I'm going to add a little bit onto that filtering data bullet point and talk about filtering data to create multiple data sets. So in this case, I have in my data statement, Asia, Europe, and other. These are the 3 data sets that I want to create, where Asia will only store the Asian cars, Europe will only store the European cars, and everything else gets into this other bucket. So if the origin is Asia, then output Asia. This is my if then. Else if the origin is Europe, then output Europe. And then in every other case, just throw it into the other data set. So this helps me create multiple data sets based off of filtering a certain feature. Okay? And notice since I have more than two conditions, I'm using if, else, if, else. If I had two conditions, I just need if and else. Okay? Now, with creating new variables, I also can do that here. So in this case, I'm creating a data set called country underscore filter. And then it's reading from my sashelp.cars data set. If the origin is equal to USA, then create this new variable called US underscore flag equal to 1. Else, set that flag equal to 0. Okay? Because maybe I need to do a classification model that's going to predict whether or not a car would most likely be a United States car or a different manufacturer. Okay? So it also helps me create features. Last but not least, we are going to end with how it can reduce code redundancy and look at do groups. But before we look at do groups, we're going to talk about the do statement. So a do statement repetitively executes a line or lines of code based on certain conditions. And you can use do statements to create do loops, which is going to be for another time. So let's actually look at this do statement. If I need to perform more than one action based off of a condition, I'm going to use a do group and do statements. Okay. Each action is a statement and must end with a semicolon. So let's look at an example. So I'm creating an example called do underscore example. If the origin is USA, then I want to do these things. Okay. So I have the keyword do, and the two things that I want to accomplish is inside here. I want to create a new variable called domestic that's equal to 1, and a new variable called origin that's equal to United States. And then I want to end that. And then I'm running that. Okay. So let's look at examples of these conditional statements right into SAS. So where did we leave off at? Okay, here we are. So in this case, this is our conditional statement with 3 conditions. I'm creating 3 data sets: Asia, Europe, other. I'm reading from the existing sashelp.cars. If the origin is Asia, then write those rows to the Asia data set here. If the origin is Europe, then write those rows to the Europe data set here. And for every other thing, I want you to just output it to the other group. So I'm going to run this. And when I look at it, it starts me off here that I'm on table work Asia, and I see that the origin is Asia. I have Europe, and I can see that the origin is Europe in this data set. And I have other, which is going to be everything else, which most likely is the USA. So this is how I created 3 different data sets stored in my work library just by using conditional logic. Here I have my country filter that I can create new variables using a conditional statement. So if the origin is USA, then create a new variable called US flag equal to 1. Everything else needs to be equal to 0. And when I scroll through, I have this US flag here, and we see that it's 0 for Asia and Europe, but when I scroll down, it's 1 for the United States. Okay. And that is our conditional logic. We also have our do statements down here, which is if the origin's USA, then create a new variable called domestic equals 1 and create a new variable that is the United States. Okay. So in this case, I have the nice little domestic equals to 0 or 1. When it gets down to 1, I have it equal to United States. Okay. So this is a nice little introduction of the data step. I hope you enjoyed it. You have learned the data step in under an hour. Please, please, please practice. Do not underestimate the power of Google. So if you want to know something about SAS, SAS is a really good language that has great documentation. Please research it. But just a recap, you have learned how to read in data into SAS, either using proc import or using infile and input statements. You have learned how to read in raw data files, such as CSV files, text files, things of that nature, as well as informats, which are used for unstructured data like dates. You have learned the different variable types, which is character and numeric. Character is left aligned, numeric is right aligned. You have learned certain functions such as the sum function, round function. You have learned functions to concatenate strings together, such as your catx function, where you can join two variables based off of a delimiter. You have learned the linked statement and the retain statement, where the linked statement can be used so you're not cutting off variable information, and where the retain statement can help you with the order of your variables in a data set. You have learned the drop and keep options and statements. So inside the set statement, you can choose what variables to keep, also what variables to drop. And you can also use those separately as statements as well. You have also used the input functions on how to change variables from character to numeric and vice versa. And you also have learned that conditional logic of if, else, then statements. Okay? So please like, comment, and subscribe. Thank you so much for tuning in with Learning with Jelly. And I look forward to teaching you on my next video. Thank you. Bye-bye.